Colin has worked at AstraZeneca for 5 years and is now a senior chemist. His job is to work out the pitfalls of scaling up drug manufacture to mass production. He's in charge of running tests in the giant reactor vessels.
I work in process research and development here in the pilot plant. Process research and development has to take novel chemical entities and essentially derive a process that will make that a marketable drug. What we do in the pilot plant here is take processes from the laboratory and work out how to make those processes ultimately on the tons that some drugs might need to be produced in. So we produce the active ingredient that goes into medicines, and we take that from the laboratory through to the manufacturing plant. We're an intermediate stepping stone, if you like. My job is fundamentally chemistry. At the end of the day, everyone understands what a chemical reaction looks like. The stereotype is of bubbling away, giving off fumes. So everybody understands that chemical reactions are energetic. When you come to do a reaction on a large scale like this, the energy of that reaction may be massive. The amount of gas that that reaction may give out may be massive. These are things that you don't have to find out in the plant and get a nasty surprise. You can do this on a bit of paper. You can write down a balanced equation for a reaction and you can calculate that and you can work out how much gas that reaction is going to give off on a certain scale. This isn't learned at university. Kids learn this at GCSE, how to balance chemical reactions. This reactor vessel here serves the same purpose as a round bottom flask would in the laboratory. It's where you mix up your reactants and you form your new product. So although it looks very complex, it is just essentially a reactor vessel that does some very basic things with some nice instruments, etc., so that we can get a better idea of what's going on. We'll do our typical reactions that will form from the starting materials, we'll form the intermediates, we'll then react those intermediates to make a final drug compound. So that might be done over a number of stages. So there'll typically be solvents in here, the powders that you'd expect to see, acids, alkalis, and we're doing standard chemistry in here to form new bonds, new functional groups, and finally turn all these starting materials into our final drug compound. So this is a schematic depiction of the reactor vessel that we were just looking at on plant. You can see that was operating some of the equipment manually at that time, but the vast majority of the processes we run are run by an automated system, what we call here a distributed control system, or a DCS. We've got feedback and feed forward, so the system can intelligently control the reaction, keep it at the maintained temperature, the desired temperature, the safe temperature.
Colin's role links directly to both Key Stage 3 and Key Stage 4 of the national curriculum, particularly around the production of new materials, the representation of common compounds and chemical formula, and the chemistry behind chemical reactions.
I work with local schools, I work with local pupils, and where I've been surprised in recent years is that even very bright 17-year-old students who are fully intending on studying science at university come here, see what people do here day in, day out as a job, and then tell me straight to my face, I didn't realise people did that sort of job. They don't appreciate what they will ultimately do with that science. So I think it's an absolute guarantee that at 12 and 13 we're losing pupils that probably are interested in science or probably enjoy it because they think it's irrelevant and think that it's nothing that they can do on a day-to-day basis in the future. So we need to change that, and I think this project should be very good to help that.
Laura Downs joined AstraZeneca after studying for a degree in chemistry and now works as an analytical chemist, helping to turn raw drugs into forms that humans can take.
I work in the development function, So with any process of developing new drugs, you have a discovery element where you're finding a drug molecule that targets something in the body to treat disease. And I work in the development function, which is where we're taking that and developing it into a medicine. So we're working on something that humans can take. So a large part of my job is formulation support. So we will be developing a tablet or a capsule or an inhaler or an injectable solution or something like that. This is our high pressure liquid chromatography kit, and we use that when we're developing medicines in several ways. One of them will be looking at all the different ingredients and components of a medicine to find out what's in there. What we'll also be using it for is to separate our medicines and look for breakdown products, so what sort of degradation we might see. So the kit itself is fully automated, controlled by a computer module. It injects automatically our sample and separates it, and using something like green food dye we're able to actually visually show how the separation occurs. The components of the green food dye have been separated into individual, the yellow having already left the column and the blue here, which is actually an individual component of that green food dye, and we're able to analyse that separately and to tell exactly what it is. When it comes to doing a demonstration like this for children, we need to use the parts of the kit that are new to them. Okay, we relate it back to what they do in the school environment, so their paper chromatography separating ink, but then we also talk about the extra parts, so what's automated, how we don't have to do any of the sample work ourselves and how it's automatically injected. So this is our automated dissolution kit. Each one of these vessels underneath represents a stomach, and we would be filling it with something which would be stomach media, so something acidic. We would also be warming it up, as you can see here, to body temperature, which is 37 degrees. We would use this piece of kit for basically looking at how tablets would behave in the body. So we have these paddles here which go into the vessels and stir, which behave like agitating stomachs when you basically put something in there. So we would drop a tablet in there and we would sample to see how our tablet is breaking down, how it's disintegrating, and then how it would dissolve, which gives us a good idea of how it would behave in the body and how long it takes for this drug to actually get into our bloodstream.
Laura's role links directly to Key Stage 3 of the national curriculum, particularly around processes and phenomena related to materials and their properties. It also relates to pupils' need to draw on scientific knowledge, understanding and using appropriate technology, for example, in the separation of materials.
Well, there's a couple of key aspects to remember when you're thinking about talking to school kids. You have to dumb down your science to a level that they understand, but not too much that they feel that they're being talked down to. You have to make sure that you're not dropping in acronyms or terminology that you understand and they won't, because that switches them off straight away. But you also have to think about real life examples where they can see what it is that you do, perhaps in a different context. So one of the key things that I would talk about is crime scene investigation, CSI, that the programme where you have forensic scientists basically using evidence to convict or to find out sort of what happened in crimes. And the equipment that they show on CSI is identical to the equipment that we use here. And we had one particular student who was planning to do pharmacy at university, and they came and did a work experience week here and did the sort of work that we do. And she changed her mind and went and did pure chemistry with the plan of becoming analytical chemistry. And she's actually at university doing that now. And that's the sort of stuff that really makes you think this is worthwhile.